Hello everyone, welcome to my channel. In this video, I am going to explain my POS system project. This system has a front end built with HTML, CSS and JavaScript and a backend built using a Spring Boot with the layered architecture. So this project backend uses layered architecture to separate responsibilities. Layered architecture is a way of organizing a backend project into separate layers. Each layer has a specific responsibility. We use layered architecture to make the system clean, easy to understand, and easy to maintain. If everything is in one class, the project becomes messy. With layers, each part has only one job. Now I show how I use layered architecture in my project. This is the controller layer. Controller is the entry point. Let me explain the annotation on top. Customer controller. First one, REST controller annotation. Tells Spring this class handles HTTP request. Return values become JSON automatically. Next, request mapping. It based URL for all endpoints. I used V1 for version. Professional practice. Next, required arc constructor. It uses Longbook generate constructor for all find fields. Spring use it to inject customer service. This is a constructor injector based best practice. Next, cross origin. Enables cross fronted on port 5500, backend on port 8080, code different ports, browser blocks by default. This annotation allows the request. Next, post mapping. Post mapping maps HTML post to this method. Next, request body. Takes JSON from request body, converts to customer DTO automatically. Next, valid annotation. Checks all validation rules before method runs. If any field fails, Spring throws exceptions. Global exception handler returns 400 code. Next, go to the DTO layer. It using all arc constructor, no arc constructor, and getter status. The DTO data transfer object layers travels between front end and back end. Why not use entity directly? Three reasons. Security. Entity might have sensitive field we don't want to expose. Control. DTO controls exactly what client can send and receive. Next, validation. Validation rules go on DTO, not entity. DTO is a shield between outside word and database object. Validation annotations. This is the validation annotation. Not blank. Means field cannot be empty. And size. Mean 10. It means 10 minimum 10 characters. Order detail. Look at item name. No validation. Total price, item names, order dates, no validation. Why? Server sets these not client, item name, service features from database. Total price, service calculates. Order date, Hibernate sets automatically. Client never send these. Next layer, entity. Entity is the database layer object. One entity class equals one database table. One object equals one row. And first one, entity annotation. Tells Hibernate map this class to database table. Next, ID annotation marks primary key. Next, generated value. Identify database auto increments ID. I use identity because my SQL has native auto increment and I used all the constructors. And this is the exception layer. This one global exception. This one rest control advice. This annotation when any exception is thrown anywhere, Spring checks this class one place for all error handling. Drive principle, don't repeat yourself. First exception handle returns 400 with record my error message and next return 404 error messages. These are the 400 code and 404 error code. Next, this is a repository layer. First one, customer repository. Completely empty, no methods, no SQLs, but has all CRUD operations because extends JPA repository. JPA repository gives save, find all, find by, find delete by ID, all free. Spring generates implementation at runtime. Zero code for me. Order repository. More interesting. Custom methods using query definition. and annotation, query annotation with JPQ for complex queries from order capital O. Entity class name, not table name. Hibernate translates to SQL. Next, service layers. This is the first one, customer service IMPA. First annotation, use service annotation. Spring registers these classes as a B. Business logic live here. This is a save customer. One line. Module map. The module mapper converts DTO to entity. Repository saves two libraries do all the work. Get all customers, find all returns entity list, Java Stream API, string map each entity to DTO using model mapper, collect back to list. Functional programming clean and expensive. Update custom. First checks if exit set ID from URL into DTO. Very important. Hibernate needs ID to know this is update, not insert. Order service IPMQ most complex. Next, go to util API response. Generic wrapper. T-type. This is a T-type parameter can be list, string, DT or void anything. Every response from every controller using this. Frontend always receives same structure, status, messages, data, API. Next, Spring Mini POS application. This is a Spring Boot application annotation. It combination of three annotations. Next, go to dependencies. Let me show from XML5. These are the libraries my project use. So Spring Boot Starter Web. I use Spring Boot Starter Web REST API support. Controllers, JSON conversions, everything. Spring Boot Starter Data GPA. This one. Spring Boot Starter Data GPA. JPA Hibernate REST repository support automatic SQL. and MySQL connector connects Spring Boot to my SQL database, and I used uh, model mapper and Lombok gives and getter setters in Lombok and mapper model mapper converts DTO to entity automatically. These dependencies they build the entire backend. Just add to pom.xml, Maven download everything. Now let me show the front-end part live. This is the home page of my POS system. From here, navigation to customer, customer, item, order. To book pages, this is the front end size. Index.html file. This page folder contains the main use interface screens. This is dashboard page. Is built using HTML, CSS and Bootstrap framework. Using Bootstrap. Custom CSS and CSS variables are used to create a consistent theme and modern UI components such as panels, action cards. Bootstrap is used for responsive layout and navigation, and its JavaScript bundle enables mobile menu interaction. And all files are same, such as using HTML, CSS and Bootstrap frameworks. And first, custom. This page allows users to add customer, update customer, delete customer, viewing customer list. This one. JavaScript sends HTTP request to customer V1 API to API V1 customer. using Ajax item at then can add items, update the items, delete and clean the items, their quantity and price. Order page. This page handle order placement. Select customer. We can select customer and ID, item name, unit price, available quantity, order quantity, and finally place order. We discuss front-end and back-end connection. Front-end sends data as JSON, back-end receive using request body. Back-end returns JSON response. Front-end updates UI dynamically. This is RESTful communication. And these database tables, Spring Boot connects to database using MySQL. Now it has customer, item, order detail, order tables. Now we go to the application properties. Properties include URL and database username, database password, JPA configuration here. Hibernate automatically creates or updates tables. Now I will explain the backend separate. Discuss it. And finally, main features of this system: CRUD operations, REST API development, layered architecture, exception handling, database integration, front-end and back-end integration. That is, this project demonstrates full stack development skills. This is the complete presentation of my Spring Boot POS system. Concepts, demos, and full code, everything explained. Thank you so much for watching. See you in the next video. Thank you.